coordinates, okay, is 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. Just looking at the x, you could do the same thing for the y as well. That's one way. Anybody else? Okay. Hold up your left hand. Okay, we good? All right, this is 0, 30, 45, 60, and 90. Okay? And imagine the denominators are all the same, right? For 30, 45, and 60. Denominators are all 2. Imagine, what is the square root of 1? 1. So all of your numerators will have the square root of, you'll see. Okay. So if I drop 30 degrees, right? How many fingers do I have? Root 3, right? How many here? 1. Root 3 over 2 and 1/2 for 30 degrees. Okay? Drop your middle finger. How many on either side? How many we got left? 1 and 3, right? Okay. Now for 0 and 90, if I drop this is my x, right? Which is 0. What's the square root of 4? What's 2 over 2? 1, 0, right? If I drop this for 90, my x is 0. What's the square root of 4? 2 over 2, which is 1. Okay? So, if you were to drop 30 degrees, root 3 over 2, and 1/2. 45, root 2 over 2, root 2 over 2. 60, 1/2, and root 3 over 2. Okay? So that's another way if you get stuck for especially the first quadrant. Once you know the first quadrant, you could go all the way around. Okay? One thing to your unit circles that you might want to add to it, just for now in terms of exact values, is in the first quadrant. Okay, so I'm going to do this on a separate sheet. Page. In the first quadrant, my x and y's are both what? Positive. So x, y's are positive. So in terms of sine, cosine, and tangent, all 3 of those are going to be what? Positive. So sine, cosine, tangent are all positive. So then, when we move to quadrant 2, what happens in terms of x and y? X is negative, y is positive, right? So all students, okay, so in terms of sine, cosine, and tangent, which one's positive? Yeah, just sine. So sine is positive, then cosine and tangent are negative, okay? Now when we move to quadrant 3, what's going on with quadrant 3? Both negative, right? All students take, so in terms of sine, cosine, and tangent, what do we got? Tangent's positive. Sine, cosine are both negative. However, tangent is positive. Then when we move to quadrant 4, this could either be labeled calculus or classes. In terms of x and y, what do we got? Positive x, negative y. And in terms of sine, cosine, tangent, what do we got? Cosine positive, and then sine and tangent are both negative. Okay? This will also help you remember exact values, okay? Also, we are going to be given, say, the tangent of theta, which is 5 over 12. You have to figure out, A, what quadrant it's in, then find the missing side length. Okay? That's what we will be seeing today. But first, for exact values on the bottom of the page, sine of 225 would be what? Sine of 225. Jaden. Negative root 2 over 2. Because let's recall, x are what values? X are what? Cosine. Y is what? And what's tangent? Y over x, which is tangent. Okay. So, cosine of 315. Eleanor. Root 2 over 2. Good. Tangent of 135. Yep. Negative 1. Good. Cosine of 120. Kate. Negative 1/2. Good. Tangent of 300. David. Negative root 3. Good. And sine of 60. Go ahead, Grant. Root 3 over 2. Excellent. Yeah. Yeah. Okay. Any questions? Okay. We want to just go through what you guys found last night. Okay. All right. So let's go through these. Okay. Page 13. All right. Just a little recap. Perfect. Good. Good angle. Good job. Very smart. Sine of 45. Riley, what do we have? Good. Root 2 over 2. Okay. Cosine of 45. Catherine. Root 2 over 2. Tangent of 45. Well, you have y over x, right? So root 2 over 2 over root 2 over 2 is just, Kaden? 1. Okay, just 1. Because this is what it looks like. Okay, denominators cancel. Same number over itself equals 1. Okay. Sine of 150, Kip. 1/2, good. Cosine of 150, Campbell. Good, negative root 3 over 2. Excellent. Okay. Tangent of 330, Zoe. Okay, good. So it's just negative root 3 over 3. Perfect. Good job. Sine of 90 is 1. Good. Sine of 135, Pearson. Root 2 over 2. Excellent. Cosine of 270, Christian. 0. Excellent. Tangent of 180, KR. 0. Excellent. Okay. One thing about tangent, right? One thing about tangent, we know at 180 it's 0. What would it be at 90? Right, it would be undefined because what's 1 over 0? Undefined, right? So tangent is undefined at 90 and where else? And 270. Okay? Tangent is undefined at 90 and 270. Okay? Because we have 1 over 0 and then negative 1 over 0. All right? So, you may notice some of these have the same value, okay, because they have the same reference angle. That's why we did the same colors. Okay, when we did the colors, they have the same reference angle, okay, hence the same colors, okay. And this is most important. A reference angle is always between 0 and 90, since it refers to quadrant 1. Okay? The reference angle is always between 0 and 90. Okay? And like I kept mentioning, you always want to look at the closest x-axis, not y-axis. Okay? Closest x-axis. So you're either looking at 0, 180, or 360, not 90 and not 270 for your reference angle. Okay? So we want to state 3 angles that have 60 degrees as a reference angle. So looking at your unit circle, what 3 angles would have a reference angle of 60? Meaning, what would have similar points, just different values? Christian, give me one. 120. If we needed to find that, 180 is the closest x-axis, or in the quadrant 2. 180 minus 60 gives you 120. Pearson, you got another? 240. Since it's in quadrant 3, 180 plus 60 to get 240. What would be another? Jax? We would take 360 minus 60, which would give us 300. So, on the unit circle, if you look, do these 3 angles have the same color that you filled in from the other day? Yeah. And they have the same coordinate, however, different values. So what do we do if we have an angle that is not seen or labeled on the unit circle? So we want to state 3 angles that have a 20-degree reference angle. Okay, I want you to think about it. What would that angle be in quadrant 2? What would that angle be in quadrant 3? What would that angle be in quadrant 4? It would be very similar to what we just did above. Okay, think about it. 1 second. All right. Quadrant 2, what would that angle be? Kate? 160. 180. Oops. 180 minus 20 gives you 160 in quadrant 2. How about quadrant 3? Noella, what would I get there? Careful. Reference angle of 20. Okay? Go ahead, Riley. 200. 180 plus 20 in quadrant 3 would give you 200. Okay, quadrant 4. 340. 360. Okay, so if you notice, 180 and 360 are our x-axis. Okay, so now we want to find the reference angle So we want to work backwards now. We want to find an angle that's within quadrant 1, which is between 0 and 90. So if I have a degree of 182, what would that reference angle be? Charlie? 2. Because 182 is in what quadrant? The second quadrant. Good. So we have 182. Oh, is that the second quadrant or, sorry, third? 180 minus 182 minus 180 equals 2 degrees. Good. 220 is in what quadrant? Yep. Quadrant 3. What would that reference angle be? 40. Good. 315 is actually on the unit circle. What would that reference angle be? Hands, please. David? 45. And 306. 306. James? 54. Excellent. Good. Excellent. Okay. So anytime you're trying to figure out your reference angle, okay, it's always going to refer back to that first quadrant. All right? Questions, comments, concerns? Okay. Turn the page. Okay. So, when we are drawing angles, okay, you always start with your initial side, which is here. That's where we always start, because on the unit circle, this point is what, or that degree is what? 0, right, is where your starting point is, at 0. So, 220 is in what quadrant? And we're always going counterclockwise. Go ahead, Charlie. The third quadrant, okay? So 220 is roughly here, okay? And how we draw an angle is that's the direction it goes in, right? Counterclockwise. Now, what would we do if we had a negative degree? Are we still going in the same direction? No, right? Because that's all of our positive angles. So instead of counterclockwise, we're going where? Clockwise. However, negative 30 will fall in what quadrant? 4. Why 4? You're correct, Pearson. Why? Okay, good guess, though. Good job. Yeah, Kate. Good. So you're still starting here. Now, if you needed to know where it kind of falls, we could add 360 to see where it falls within the unit circle. And what do we get? 330. So 330 and negative 30 are going to have the same coordinate point. Okay? So we're right here. Okay. Now negative 270. Where would that fall? Jax? 90, good. So again, we're starting here. Count clockwise. This is where we end. Well, now we have 405. Is that greater than 360? Yeah, so we completed one full rotation. Where do we end up? 45. Good. You subtract 360. Okay. So again, we're still starting here, and since it's positive, go counterclockwise. And at 45. You guys try 5, 6, and 7. Okay, try 5, 6, and 7. All right, negative 240. All right, so we're going clockwise. Jaden, what quadrant do I end up in? Quadrant 2, good. Because it's equivalent to 120. Excellent. Good. Nice job. Okay. Number 6. Tommy, negative 180. Where do we end up? 180. Perfect. Okay. Okay. Now 161. What quadrant? Grant. Quadrant 2. Excellent. Good. Excellent. Okay. How many of you guys got that? Perfect. Okay. So what we just did by drawing angles, we are looking at coterminal angles, okay, where the angles end in the same location. So for example, negative 240 is the same as 120. It's equivalent to 120, okay? Negative 180 is equivalent to 180. So for any one of these, if I wanted to find the sine of negative 240, God bless you, or the sine of 120, I know it's going to be what? What would be the sine of negative 240 or the sine of 120? What would that be? It's your y value. Root 3 over 2, okay? They would both have the same value, okay? Sine of negative 240 and sine of 120 would both be root 3 over 2, okay? Those are called coterminal angles. So for example, seeing them side by side, we have 30 degrees, okay? That's within our quadrant 1. Here's 30 degrees. Now 390 completes how many rotations? 1, right? Are we going to end up at the same spot? Yes. Okay. So again. Okay. That is 390. You're ending in the same location, however you completed one full rotation. Okay. So now, what is the coordinate point at 30 degrees? Yeah, David. Root 3 over 2 and 1/2. Is it the same for 390? Yeah. Okay. Because 390 and 30 are coterminal angles. Okay. So now if I wanted to evaluate, the sine of 30 is what? 1/2. What is the cosine of 30? Good, root 3 over 2. What would be the tangent of 30? Go ahead. Root 3 over 3. Good. Because it's y over x good. Okay. Will you have the same values for sine of 390, cosine of 390, and tangent of 390? Yeah, it would be exactly the same. Okay, so even though they completed more than one rotation, okay, or if we went the negative, so for 30 and 390, what would be a negative coterminal angle? What would be a negative coterminal angle? Kate? Negative 330. So if we took 30 minus 360, we get negative 330. Okay. However, negative 330, okay, negative coterminal angle, your coordinates might be a little bit different. Okay? All right. So, if we were given the angle of 50, okay, we want to find a positive coterminal angle. So meaning, if you're in 50 in quadrant 1, you're completing one full rotation. So what do we have to add to that? 360. So positive coterminal angle is 50 plus 360, which is 410. Okay. A negative coterminal angle, what would we have to do? Subtract. And what do we got? Grant? Negative 310. Negative coterminal angle will have a negative sign. Okay? Now you guys try. Negative 212. All right. What would be a positive coterminal angle, Victoria? 148. Excellent. Okay. You could even add 360 again to get another positive coterminal angle. What is a negative coterminal angle, Ryder? Good. Negative 572. Excellent. Okay. So now, use what you know about coterminal angles, reference angles, and the unit circle to evaluate without a calculator. So we're going to do this first one together. Okay? We're going to do this first one together. So, the sine of 225 is in what quadrant first? It's in quadrant 3. Should the answer be positive or negative? Negative. Good. What is the reference angle for 225? David? What is it? 45. Good. Okay. Now for coterminal angles, I want you to find one, excuse me, one positive and one negative. Okay? What would be a positive coterminal angle? Okay? 225 minus 180. Okay, that's how you get 45. Okay. Positive coterminal angle. Yeah. 585. What is a negative coterminal angle? Go ahead, Kaden. Negative 135. Now, my question to you is, the sine of 225, what is the exact value? So it's going to be, what? Yeah. Negative root 2 over 2. Okay? So, I want you to try some practice here. Okay? I want you to work together. Okay? So get together with a partner, and I want you to work on these 5. Okay? So I know the numbers are a little crazy, but BC and then ABC. Okay? I want you to give it a try. Do you guys want me to go through one more before you get to work? Okay. Those of you that want to get to work, go ahead. Those of you that need another try, which one? Which one you want to go through? The second one? Okay. Cosine of 405. First find out, where is that going to land? quadrant 1, right? Because 405 minus 360 is what? 45. So that lands in quadrant 1. Is that going to be positive or negative? Careful. Positive. Okay? Because it's a positive coterminal angle as it is, so it completes one full rotation and we're getting back to quadrant 1. Okay? The reference angle is 45. Okay? The reference angle is only between 0 and 90. Okay? So one coterminal angle, positive, you could do two things. Okay? You could say it could be 45, or you could take 405 plus 360. 765. Okay? What would be a negative coterminal angle? You have to keep subtracting 360 until you... What is it? Careful. Negative coterminal. Huh?
Would it be negative 315?
Negative 315. Okay, so it's 405 minus 360. We're still in that positive zone. Then you have to hit negative again. Yep, your negative coterminal has to be negative. So you keep subtracting until you get negative. If you were given a negative angle and you need a positive, keep hitting add 360. So if I needed to know the cosine of 405, which is the same as 45, what would that be? Root 2 over 2. Okay? All right? Take some getting used to. It's asking you a lot here. One positive, one negative. I added to that. One of each. Okay? Just to get familiar with that. All right? Help each other out, you guys. Work. All right, tangent of 315 is in what quadrant? Let's see. All right, be ready to answer. Okay, Nick. 4. Okay, it's in quadrant 4. Riley, should the answer be positive or negative? Negative, excellent. Reference angle, Catherine. 45, excellent. All right. One positive coterminal angle, Jax.
675.
Good. What is one negative, Kip? Some of you, yep, good. Excellent. Any questions? Oh, tangent of 315 is what value? -1. Excellent. Good. Yep.
How do you get that angle?
Reference angle is in quadrant 1.
Yeah.
Always. So if this is in quadrant 4, 360 minus the angle. Okay, in quadrant 4. In quadrant 3, to find the reference angle, it's the angle minus 180. Okay, in quadrant 2, to find the reference angle, it's 180 minus the angle given. Okay, all right. Sine of 510, Campbell, is in what quadrant? 2. Excellent. Would this be positive or negative, Zoe? Positive. Good. Reference angle, Kate Murray. Did we get 60? 30. Reference angle is 30. If you keep subtracting, when you subtract 360 once, what do you get? 150, right? If you subtract it, if you take 180 minus 150, what do you get? 30, and that's your reference angle. Okay? Coterminal angle, give me one, is -210 is our negative coterminal angle. Kaden, give me a positive. 870. Some of you might have had 150. Okay? That's a coterminal as well. Okay? What is the value of 510. Pearson. Yeah, exact value either. Okay. All right. Christian, do you have that? 1/2. Good. Okay, 1/2. It's okay. All right. Now, tangent of 600. What quadrant, KR? 3. Good. Excellent. Would this be positive or negative, Noella? In quadrant 3, both x and y are negative, right? Positive. Good. Okay. All right. The reference angle, David. What is it? 60. Good. Okay. One coterminal angle, Eleanor. Negative what? 120.
Also,
240 and 960. Okay. What would be the value of tangent of 600, James? √3. Good. All right. And the last one, cosine of 750. Jaden, what quadrant? 1. Okay. Charlie, positive or negative? Positive. Reference angle, Tommy. 30. One coterminal angle, Grant. Good. Okay, I'm going to take a few for this. Victoria, another. Okay. Ryder, you got one for me? 390. And what would be a negative? Go ahead, Kaden. Negative 330. 30 would be the reference angle. Okay. It could be a coterminal angle too, actually. All right. Cosine of 750 would be what value? Anybody? √3/2. Good. Okay. So what we just did was a lot. Okay. In terms of, we have one more thing to do. With all of this, the reference angle, remember, is always going to be in that first quadrant, 0 through 90. Okay. Always going to be in that first quadrant. Coterminal angle, you positive, you add 360 to the given angle. Negative, you subtract. Now, for 750, when we keep subtracting, if we subtract once, are we within 0 and 360 yet? No, you have to subtract again, okay, in order to get to see where it falls within the unit circle, okay? The last thing is, if you are given, okay, a point, okay, if you are given a point, first you have to identify what quadrant it would be in just based on x and y, okay? But I want to show you when you draw these triangles, how they would end up being, okay? Doesn't matter what quadrant they're in, okay? If you have a point that is in quadrant 1, you're drawing your triangle this way, okay? If you have a point, and I'll get to why we're drawing triangles in a second. If you have a point that is in quadrant 2, you draw it this way, okay? If you have a point that is in quadrant 3, this is what you're drawing, okay? If you have a point that is in quadrant 4, this is what it's going to look like. The reason I'm going through this, I see triangles written all different ways, but you're coming from the central angle, okay? So you're coming from the origin, going out, and then down, okay? So, if we look at the point 8, -6, where would that fall? Quadrant 1, 2, 3, or 4? 4, quadrant 4. So when we draw our triangle, oops, center of the origin, then you drop your perpendicular line. Okay? Now we have our hypotenuse, which is there. But 8 is what value? X or Y? X. So would it go here or here? Horizontal or vertical? Horizontal. So this is 8, and therefore this would be -6. So how can we find sine, cosine, and tangent? What do we still have to find? A squared plus B squared equals C squared. We need to find the hypotenuse. Okay, so you have to use A squared plus B squared equals C squared. In this particular problem, we are finding the what? Hypotenuse. Go ahead and find it. Let me know what you get. Yeah, Kaden. Oh, you have the answer. Give me 1 second. Everyone have the answer ready? Go ahead, Kaden. It is 10. Okay? And we're just going to leave the answers as is. We're not going to reduce. We're just going to leave it. Okay? What would be the sine of theta? And remember, this is where your angle is coming from. Sine of theta would be what? Go ahead, Grant. Okay, we're just going to leave it for now as is, but you are correct. -6/10. Good. Cosine. 8/10. Good. Just so you guys can refer back to this. Tangent would be what, David? -6/8. Good. Okay. Now if we look at example 2, what quadrant? 3. Okay, quadrant 3. So draw your XY. Quadrant 3. Okay. -2 is our X. Start with -1. We have to find our hypotenuse. So go ahead and find your hypotenuse. This is Go ahead, Jax. Not I√5. Be careful. We shouldn't have a negative there. You're squaring both of those negative signs. Grant. Just √5. Okay? Just √5. So, remember it's -2 squared, C squared, 4 plus 1. Okay, so what would be the sine of theta? What would be the sine? Kip. Good, -√5/5. What would be the cosine? David. -2√5/5. And then tangent. Go ahead. 1/2. Okay. So that's when you're given a point. Okay. You have to determine what quadrant it's in. Draw your triangle and find your missing side length. Then find the exact values for sine, cosine, and tangent. Okay. Now, what do we do in this case? We have the tangent of theta, 5/12, where sine is less than 0. Okay? Find the exact values. So, first I want you to think, where is tangent positive? What quadrants? Quadrant 3 and, Ryder? Quadrant 1, right? So 1 and 3. Out of 1 and 3, where is sign less than 0, meaning negative? Go ahead, Ryder. Quadrant 3. So tangent of theta, 5/12, is in quadrant 3. Okay? However, to get tangent, what is that made up of? What is tangent made up of? Yeah. Okay. Opposite over adjacent. In terms of x and y, what is it? Yeah. Okay, good. Yeah, Jaden. Y over x, right? So, but this is a positive fraction. So how can I fill out my triangle? Kate? Good. -5, -12. Because both x and y are both negative. To get your tangent, it's positive. So how do we find the hypotenuse? Good. Yeah. Why? Hold on. Let her go ahead. Why? How many of you caught that? Eleanor, repeat loudly what you just said. She is correct, by the way. Go ahead. Okay. Why? You said it perfectly before. Excellent. Good. So, here, this is tangent is y over x. So, we should have -5 here. And our -12 is our x value. Correct. Excellent. But you still have to use a squared plus b squared equals c squared. Yeah. You could do that as well. Yeah. So what is our hypotenuse? 13, right? All right. So now, what is the sine of theta? Kate? No. Hypotenuse is always positive. It's always positive. I'm glad you brought that up. Hypotenuse is always positive. Okay? What would this sine be? Yeah. Cosine. Good. Now, the reason it wouldn't be, Kate, negative, then you would end up with a negative over negative, which would make that positive as well. But your hypotenuse, I'm glad you brought that up, is always positive. Okay? You might be asked what the exact values are, right? Say if we're just in the positive zone or whatever, and we're finding a missing side length. When it asks for exact values or all the possible values, before we did the square root, or even here we did the square root, you would always include plus or minus, okay? But if it's just strictly what are the exact values, you're going to use the signs given, okay? So I want you to try one on your own. The last one on the next page, and that's it. Yeah. For this one, what quadrant are we in? Nick? 2. Good. What is our missing side length? Kate? 4. All right. And last but not least, what is the sine of theta? Go ahead, Kate. 4/5. Good. What is the tangent? Riley? Thing. -4/3. Good. Excellent. Okay. Questions? Comments? Concerns? Yes. Quadrant 2? Okay. Cosine, first determine where cosine is negative. So cosine is negative in 2 and 3, right? Cosine is negative in 2 and 3. So therefore, you then look to see where tangent is negative, okay? Tangent is negative in quadrant 2, positive in quadrant 3, okay? So knowing what's positive where is key, okay? All right. You guys, your homework and your practice is in the green packet. Okay. 6-2 practice, 6-3 practice. It says on the top on pages 3 through 5. All right. Awesome job.